Why should we learn a little bit more about the melting ice sheets of Greenland? Some of us would have to Google to find Greenland. According to a CNN report, the Greenland ice sheet dumps more than 280 billion metric tons of melting ice into the ocean each year. And we are here to talk more about why that is important for our future. This episode is all about the melting Greenland ice sheets, and we will talk to one of its foremost experts on the topic, Dr. Åsa Rennermalm, an associate professor at Rutgers University who studies hydrology, climatology, and the Arctic region. Let's talk a little bit about the ice sheets. Before we dive a little bit deeper into it, what is an ice sheet, and why is it important?
Yeah, very good questions. There's actually two ice sheets on planet Earth, and one is the Greenland ice sheet, and the other is the Antarctic ice sheet. And they are the biggest bodies of ice on the planet. And together, it's like they contain actually most of the fresh water on Earth. So they are a huge freshwater storage. And the reason they're important is because they store so much water. And what's happening right now is that the changing climate, which has led to pretty strong increasing temperatures, particularly in the Arctic, is resulting in these ice sheets melting. So a lot of this water is now flowing out into the oceans and leading to sea level rise, especially from the Greenland ice sheet, yeah.
Oh, wow, okay, cool. You mentioned there's two different ice sheets on the planet Earth.
Oh, yeah. Maybe I should explain a little bit more about ice sheets. So ice sheets, it's like essentially huge glaciers, right? So they form on land, and they're formed by snow falling and not melting out completely in the summer. And over time, it builds up, and it builds up this giant body of ice. So snow that's compacted by more snow falling on top of it will eventually become ice. So glaciers and ice sheet, it's not like, a glass of water. If you put it like ice cubes in a freezer, right? You pour water in some kind of container, and then you put it in your freezer and you have ice. Okay, that is not the kind of ice you have in glaciers and ice sheet. It's snow that's been compacted to ice over very long times.
Wow. Okay, that's interesting. But you're talking about the two different ice sheets that are in on the globe. The melting of these ice sheets, how do you know it's melting? Because it's so vast. I mean, there's like miles upon miles of ice sheets. How do you know that, as a scientist, how do you figure out that it's melting?
That's a great question. How do we know? And we know from, we have multiple pieces of evidence, scientific evidence, that is demonstrating that it is melting. One of the perhaps most compelling pieces of instruments is two satellites. They're called GRACE satellites. They are actually measuring gravity anomalies from space. Now that may sound complicated. Essentially what these satellites are doing is weighing Earth from space, okay? And it can record like how the weight, the mass of Earth is changing in certain locations. And over the Greenland ice sheet, you can see from these satellites that mass is that it has been losing mass. So this satellite's been operational since the early 2000s, and it's like these amazing time series from 2000 till today. There are recordings throughout the years, so you can see like in the winter the mass of the ice sheet increases, because of snowfall. But then in the summer, it goes down. And the reason it goes down is because of melting on the surface and breaking off of icebergs wherever the ice sheet enters the fjord. And that time series is just showing us that since 2000, the early 2000s, the Greenland ice sheet has been losing mass. There's more mass lost than added. So satellites are important. There are some other pieces of evidence too, like models, and also other, like you can do field measurements. Like I can tell you, for example, about some field measurements I have done where I've been able to see climate change in Greenland, for example.
What is causing this melting to happen at such a rapid pace, I'm assuming, and the breaking off at icebergs and all that?
Yeah. Okay. The cause of climate change in the Arctic is it's due to, it eventually links back to human releases of carbon dioxide. All right. Mm-hmm. Burning of fossil fuel emits carbon dioxide into the atmosphere. And that's a greenhouse gas. Okay. And what the effect of that greenhouse gas is a warming Earth system. Mm-hmm. And nowhere on the planet is the Earth warming as fast as in the Arctic. The warming in the Arctic is about double the warming elsewhere. And the reason for that is because all kind of feedback effects. Okay. You have a little bit of warming in the Arctic. What that means is like you're going to melt sea ice covering the Arctic Ocean. You're going to melt snow and expose dark land below it. And that will affect the surface energy balance of the surface. And essentially, if you melt, so it's so close to the freezing point.
Okay.
And in some places, right? And so if the snow disappears, and exposes you, I don't know, like if you go out like on a snowy day, right? Mm-hmm. You have to really be careful. You have to put on like sunscreen and stuff like that, because a lot of solar radiation will be reflected back on your face, right? Because the snow is such a bright surface. All right. Now, if the snow is gone, what's below it is this dark ground, and you will not have the same problem because a lot of the solar radiation will now be absorbed by the land and it will heat up the land. So when you reach that sweet spot where snow disappears, mm-hmm. the warm will warm up even more. So you have that. That's one of the reasons you see much more warming in the Arctic.
Oh, wow.
Absolutely. In fact, when I've done field work on the Greenland ice sheet, when I've been like way up on the ice sheet and it's cold, but the solar radiation is very strong. So I wear these totally dark glacier goggles that are super strong. And I'm actually I often cover up my face, not so much to protect myself from the cold as to protect myself from the sun, because you just get burned, you know?
Oh, wow. Okay. So this melting that's happening, I'm sure it's affecting the climate globally in some form or shape. Could you explain a little bit about that?
Okay, so there are several ways that the melting of the ice sheet can have global impacts, but the most worrisome at this point, I would say, is its potential to raise global sea levels. Mm-hmm. All right. And both the melting of Greenland ice sheet, Antarctica, and glaciers spread out, across the world, is one of the leading causes of the current sea level rise that you can record with instruments and satellites. And it's projected to increase into the future. And so that is the most, I would say, one of the most worrisome ways that the ice sheet can affect the Earth. So, and it also will put in fresh water into the ocean, and it can influence living conditions for marine ecosystems and ocean currents. But I think for most people, they would think about the impact of sea level rise from melting ice sheets.
Absolutely. Is there a difference, because I wanted to be clear to our viewers, is there a difference between the weather and the climate? Because a lot of people sometimes conflate the two or confuse the two things together, and I do sometimes myself. If you don't mind explaining that a little bit for me.
Absolutely, that's a really great question, because the big difference between climate and weather is that weather is what you experience every day, right? It's like changes in conditions from day to day. Like one day is warm and sunny, and the next is like cold and dreary, right? And then you might have like 1 year there's going to be like a super cold winter. The next year might be like a warm winter. You could have a warm summer or a cold summer, right? So weather is just day-to-day variations in sort of in climate conditions, like or day-to-day variations in temperature, precipitation, winds, and so on. Like it's like our day-to-day experience of what's going on around us. And climate is weather over long timescales. Okay, so it's entirely possible, despite the fact that we are in a changing climate right now, we can still have a winter that's cold. All right. That's more weather, it's like a departure from the mean. But the long-term trajectory, that's climate. Yeah. Okay. So we're talking about decadal changes. That's climate.
Okay. Good. I thank you very much for explaining that.
Can I point out another thing when it comes to that?
Absolutely.
All right, because there is actually, so if we talk from the perspective of the United States, right? So there is actually a research field that is investigating some counterintuitive impacts of climate change. The fact that, climate change could lead to colder winters in some places. Okay. Because it changes, the way that the large scale atmospheric patterns is changing too. So you could have more stable conditions over parts of the United States, for example, in the winter. Okay. That didn't used to be so persistent, but because of the rapidly warming Arctic compared to the polar regions, you might see, certain patterns. The duration of those sort of cold patterns could become longer and more persistent because of climate change. All right, this is like state-of-the-art research right now, but I just wanted to put that in because it's sort of. I know a lot of people think, oh, well, last winter was so super cold. Like, how can we be in a climate change? Well, it's because, first of all, it could be actually a side effect of climate change, or it could just be a departure from the mean. But what you have to look at is the long-term trend. And there are, even station data that goes back to the 1800s. You can see this trajectory of increasing temperatures across the globe, and particularly in the Arctic.
Does that have an effect on it, or how does that play into, the climate change?
The weather is going to continue to have a kind of a wide range. So, we humans haven't been around on Earth that long. Our civilization is we haven't had this kind of civilization for very long. If you look at the geological timescale of the Earth, the Earth being like 4.6 billion years old, and humans have been around maybe 100,000 years. Our civilization goes back thousands of years. We have had, so you're gonna see, and if you look back, like at the climate records, one of the most amazing records of climate actually comes from the ice sheets. Okay. Because you can drill like ice cores all the way to the bottom of the ice sheet. And we're talking about miles of ice cores, and you pull those out and you analyze them, and you can reconstruct climate back thousands of years. The longest record I've seen goes back like 800,000 years, and you can see how climate changed historically. We're always going to have that kind of variability, but what's happening right now is like you have variability imposed on warming.
Okay.
Understanding climate change is so difficult because the cause and effect is not always clear. We know that increasing carbon dioxide in the atmosphere will lead to warming. But,
effects.
tracing back like exact causes and effect is harder. It's like, the coronavirus, it came from somewhere. It affected people everywhere. You can see the cause and effect on that one pretty clearly. But climate change is more diffuse because it's the way we live, like the way our society is constructed around using fossil fuels.
So what are the impacts of the rising sea levels?
So one thing is that we're gonna see, of course, an increase in sea levels, right? And in many places around the Earth, you have a lot of populations are living close to the coastal areas. So it's going to be a huge problem for all populations living on low-lying coastal areas, all right? Okay. But there's another effect too. And so I live in New Jersey, right? I work at Rutgers, the State University of New Jersey. So here I feel like we have sort of a test case of what the future holds in when Superstorm Sandy hit, right, in 2012. I mean, most people that were at least grown-ups at the time when Superstorm Sandy hit. I mean, it's a everybody remembers it. It was like an enormous event, right?
Yeah.
Okay. So what happened during Superstorm Sandy was that the storm surges caused enormous damages. All right, so the storm surge storm surge happened during high tide. All right, and that made those storm surges even worse. So you have the combination of high tide and then wind that is pushing up the water level onto land. Now, if sea level increases, it's just going to elevate the sort of the lower boundary for the storm surge. So it'll most likely result in even worse storm surges. So sometimes I think of Hurricane Sandy or Superstorm Sandy as kind of a harbinger of what might come. Because if we have increased sea levels, that you could then the high tide might be like our average sea level in the future. Like what was high tide in 2012 is some point going to be our normal tide. And then we're going to have another high tide on top of that. So the impacts of storm surges are probably going to be worse in the future because of sea level rise.
Okay. So there's sea level rise. And I've heard scientists talk about the rising temperature of the sea. Is there something you can talk about a little bit about that? Because I figured if the melting ice sheets, into the sea, it's gonna either. I'm thinking about putting ice cube in warm water in a cup. It makes the water cooler, but I think it might be a different effect. Could you explain that a little bit more?
Yeah, because, all right, so if you look at all the water in the Earth system, if you have, about 97% of that water is in the oceans, okay? Yeah. 97% of all water on Earth is in the oceans. 3% is fresh water.
Wow.
Most of that is it is going to be in glaciers and or most of the surface water is in glaciers and ice sheet. So it's it is nothing compared to what's in the ocean. Although Antarctica and Greenland contains a lot of water, and if you would melt all of Greenland, you would raise global sea level with a roughly, between 6 and 7 meters. Okay, that's equivalent to about 20 to 23 feet, something like that. Wow. But it's nothing compared. I mean, that's going to have a big impact for us as humans, but for the ocean, it's not that much. But certainly, like it turns out though that the Greenland ice sheet is near locations of what's called deep water formation.
Okay.
And there's such a thing called thermohaline circulation, which is driving a system of ocean currents that is redistributing heat across the Earth system. Essentially, the main effect of that is that it's transporting excess heat at the equatorial areas to the polar regions. All right, so there's a whole system of currents. It's really fascinating. You should check that out sometime. It's called like the ocean conveyor belt. All right.
Okay.
So the thermohaline circulation and the deep water formation site is like an important part of that circulation, and those and some of that occurs, or the most important spot is occurring in the North Atlantic, close to the Greenland ice sheet, and it is sensitive to the salinity of the ocean. So when the ice sheet is melting and releasing, well, it's always going to melt in the summer, but if you have increased fresh water escaping from the ice sheet into the ocean, there is a possibility that it could influence this thermohaline circulation. And there's a lot of research going on to figure out, is this happening? Is it, some of the climate models suggest that there will be a slowdown of this circulation if we continue with warming and melting into the future.
Awesome. What is an acceptable rate of melting of the ice sheets? Or is there an acceptable rate of melting in the ice sheets? And how do you measure that?
Well, I mean, to me, it all comes down to what kind of world we want to live in, Like what kind of future do you want? It's not set in stone.
Okay.
And that's why when we talk about future climates, it's called projections. And there are multiple projections for future climate. And what climate researchers are doing is constructing different scenarios of the future where, in some futures, we're just going to continue like we're living now. In some futures, we might choose to kind of restructure our society to be more sustainable. Populations going to have a big role on how, the size of the global populations and so on. So it really ties into everything that makes us humans, essentially, like what the future can be like. And so the future is not set in stone. It depends what future we want, right?
Okay.
We could, in 2050, sort of projections now is that we're going to be about 9 billion people on Earth. But, we could also, maybe we want to be 50 billion people and eat algae, but...
Or replicators.
It's basically what... The issue I see with climate change is is how it affects our society. Our society is vulnerable to climate change. Yeah, it depends. What kind of future do you want?
A future where we can actually breathe and live a little bit comfortable, at least. Thank you.
Well, a lot of people don't live particularly comfortable today on Earth, right? So
that is true.
And so it's also about ties into environmental justice, social justice. Like these impacts of climate change are not going to be uniform across the Earth, and some populations are going to be hit harder than others. According to the projections that pretty much every projection I've seen means increased melting, and we would have to. I think at this point it's very hard to imagine that we're not going to have to adapt to climate change. I think we need two things. We need to adapt to climate change, but we also need to try and reduce climate change in the future.
Okay. Well, which leads me to my last questions. for our viewers, what recommendations would you give to them to help out? I know everybody's not a scientist, and everybody doesn't have, connections to everything, but I'm sure there's something that we can do to help.
Yeah. I mean, honestly, like everybody's needed. Everybody's needed to understand, to make this world, a good place for humans to live on. And I mean, as a scientist, what I feel I do, I'm telling you, we have a big problem. Mm-hmm. I'm telling you, I've been in the Arctic, I've been to Greenland, I've been doing research in Greenland for over 10 years, and I'm here to tell you that it's changing rapidly in the Arctic, and it's going to come and change the rest of the globe as well. And I think people are starting to get the message now, mm-hmm. but I'm here to tell you that. I'm telling you, we have a big problem, and I can tell you specifically about the Greenland ice sheet. That's going to impact global sea levels everywhere. Some projections suggest up to 1 meter, that's about 3 feet sea level rise towards the end of the century. It's going to have huge impacts if we don't do anything, okay? And because it's going to affect, it affects coastal areas, but mm-hmm. that is going to have effects on the people living inland too. If you have to have mass changing the whole structure of the coastal areas, people migrate, it's going to have an impact everywhere, okay? Absolutely. So where do I want to go with this? The point is, and that's me as a scientist telling you this, like looking at, the physical nature of the earth, and I can report it's changing, we have a problem. But we need everybody to figure out what we can do about it, and everybody can figure that out for themselves too. Like as an individual, I would recommend, get informed, mm-hmm. what is going on, educate yourself. Absolutely. And I think as an individual in for example, the United States, you have you're a voter. Okay, make your vote count. Put pressure on your politicians. And then educate yourself about different options that you can do. And I don't feel that it's my role to tell people exactly what they're going to do. Mm-hmm. I mean, I could say stuff like, oh, put solar panel on your roof. But if you don't have a roof or you don't live on a house, mm-hmm. it doesn't make any sense. So I feel like as an individual, you kind of have to take sort of a holistic approach. Like I've been able to live really close to my work. So I don't even have to use my car to go to my work. I can bike. That's terrific, right? Absolutely. Other people may have other things they can do, but essentially we have to reduce the take-home messages. We have to reduce the amount of carbon dioxide and other greenhouse gases that are emitted into the atmosphere. And there are many ways that this can be done. Individual action is probably not going to be enough. And that's one of the reasons I don't want to tell you, oh, stop eating meat, become a vegan or a vegetarian. Because then people might be complacent and think, well, I've done my part. I became a vegetarian. And I'm sorry, it probably will not be enough. You're going to have to do more than that.
Absolutely. I'm sure there's organizations out there that actually is trying to make a bigger impact. People, participating in that, as you mentioned before, talking to your local council person, congressman or senator, let them know that you're concerned about the environment, and that for them to elect laws or draft laws that will help the environment and to help our future generations. So I definitely want to thank you for joining us today, and I think our viewers have gotten a lot of information, and they've learned. I know definitely I've learned a lot throughout this interview, and thank you very much. I appreciate it.
Well, it was a pleasure. Thank you.
Thank you.